With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given that a cell reaction Zn+2Fe3+ gives 2Fe2+ plus Zn2+. Works at 25 degrees centigrade with the EMF 1.2 volt and 45 degrees centigrade with the cell EMF 1.718 volt. Assuming delta S0, that is the entropy, to be constant in this temperature range, calculate delta S0 approximately in kilojoule per Kelvin. So let's see first of all what is given to us. We have been given at temperature T is equals to 25 degrees centigrade and at temperature T is equals to, let's say, T1 and T2 is equals to 45 degrees centigrade. So we have been given that E1 will be equals to 1.2 volt and this E2 is going to be 1.718 volt, right? Now what we need to calculate, we need to calculate the change in EMF in between these two temperature range. In between these two temperature range, what will be the change in EMF? It can be written as 1.718 minus 1.2. This will be the change in EMF, that is E2 minus E1. So this is the delta E, we can say it is the change in EMF. So this is 1.718 minus 1.2. Now let it be like this. Now what we want to calculate delta G first, because for delta S calculation we require the value of delta G, which is gives free energy, given by this equation minus NF delta E. Fine, minus NF delta E. Now what is the value of F? The value of F in kilojoule is 96.5 kilojoule per mole per volt. This is what the value of value of Faraday is, 96.5 kilojoule per mole per volt. Now, so from here we can write what is the value of N here. So in this equation, if you will find, the value of N will come out to be, N will be equals to 2, because the change of electron, if you will see, from Fe3 plus to Fe2 plus and from Zn to Zn2 plus, it's the change of electron. The change of electron is 2. So that is why N is equal to 2, because Zn plus 0 to plus 2, or for 1 mole of Fe the change is 1. So for 2 mole the change is 2 electrons. So the total change is of 2 electrons, right? So we will put the value of N here as 2 minus 2 into, what is the value of F? It is 96.5 into, what is the value of delta E? It is 1.718 minus 1.2. So this is the value of delta G, which will come out to be, delta G will come out to be around minus 99.974 kilojoule, right? This will be the value of delta G. Now, delta G can also be written as delta G2 minus delta G1 for equation 2, that is at temperature T2, and for equation 1, that is at temperature T1. So if we calculate the value of delta G2, then we can write it as delta H minus T2 delta S, and for delta G1 we can write delta H minus T1 delta S. This is the fundamental equation. We all know delta G is delta H minus T delta S. So from this equation you can write down that delta G1 will be equals to, delta H is 0, because if the reaction is taking place at the same temperature, if it is at a constant temperature of 25 degrees centigrade, first the reaction took place, then at the constant temperature of 45 degrees centigrade the reaction took place, so delta H can be taken 0. So finally delta G1 will be minus T1 delta S, or you can write it like this, minus of, what is T1? T1 is 25, so you can write down like this, minus of, what is T1? 273 plus 25 in Kelvin into delta S. And similarly delta G2 you can write like this, minus T2 delta S. So it will be minus of 273 plus 45 into delta S, because delta S will be same in this constant temperature range, in this range. Now you can easily write delta G will be delta G2 minus delta G1. So we have seen what is delta G2. It is minus of 273 plus 45 into delta S. And what is delta G1? So minus of minus 273 plus 25 into delta S, right? So from this equation, you will finally get the value. If you can take delta as common, then you will get this value as minus of 273 minus 45 plus 273 plus 25, right? So this value you will get it as, here you can see this 273 and this 273 is gone. Now finally you can write down minus 45 plus 25, so this will be minus 20 delta S, right? This is minus 20 delta S. So finally you have got the value of delta G from here. This is nothing but this is delta G. This is delta G. So delta G is minus 20 delta S, and we have also calculated delta G is this value. So now on equating you can write down delta G is minus 99.974 kilojoule, which will be equals to minus of 20 delta S. So finally from here you will get the value of delta S as 99.974 minus divided by minus 20 which will be equals to, it will be 4.998 kilojoule per Kelvin, or approximately to the nearest integer you can write down 5 kilojoule per Kelvin, and hence this will be our required answer. So let's see which option is matching. You can see here, yes, option C is matching, so the correct answer is option C is correct. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.